So
Okay,
this is
Devam,
what.
live streaming is started. Okay.
Yes. So for people seeing live stream, just a quick recap that if you are checking the test cases of DPPs, what you can do is you can go to that particular problem, you can go under submissions, click on view results of your submission, and you will find this test cases. You can click on download and then input or expected output. Click on input, it will redirect you to a different page which will look like this. So these are your test cases. Okay. Now coming back to today's agenda. So today's agenda is majorly we'll be discussing DPP questions. All right. So starting with the we'll skip the 1 mark questions because many attempted it correctly, almost 100%. So we'll start with the fifth question. So 3 mark question and 5 mark question. So first 3 mark question. So in the first 3 mark question, which was about insertion sort, you had already given a sorted list except the last element. Yes or no? Thumbs up, thumbs down. Everyone understood this question, right? No doubts in understanding the question. So the last element, except this last element, all the elements in the inputted string are in order. So you had to fetch the values from input and then give the particular output through function. And you had already given the template code something like this. So you have all the necessary libraries imported, and you also have to not worry about receiving the input and formatting the output because it was already given here. All right, because here this part was already there in your code editor, right? Thumbs up, thumbs down. Yeah. So first let's understand how do you take those inputs and convert it into numbers and list. So if you see here, what is the input like? The first number is number of elements in that particular next line. So you have 5 numbers. So you have 5 elements. So what you will do is first you will take this input, you will convert it into string. And why are you using string? For example, sometimes it so happens that you give an input something like this 2 or else 5 space space, but this space cannot be converted to integer, hence you strip it, and after stripping it, it changes to 5. Okay, so this is your strip, because here you did not give any input to the strip function. It will remove all the starting white spaces and ending white spaces. So anything before the string character or after the string character. But now let's say you had a sentence, we are learning, then it will only remove this spaces and this spaces, not the spaces in between. Okay, remember that. And after you take that n, what you can do is the next output is only of one line, right? So what you can do is you are taking that input, you are stripping any spaces and you are splitting it. What you are splitting it with? Space. When you do not give any input in the split, it splits the string with spaces. So because you have space here, after each number, it will change to individual values. Okay. Doubts, I'll take it afterwards. What you can do is you can keep asking doubts in chat box. And yes, Karthik sir.
So like I would be requesting please turn off the mic also.
Yeah, I'll do that. Yep, I have done that. Yep. So here you are taking this input, you are splitting it with no inputs. That is, it will by default take space. If name वाली condition क्यों लगाई है? If name किधर लगा है? Okay, yeah, this I'll come to it afterwards. First, we'll understand why this. Okay, I'll come to this afterwards. Okay, all right. For now, what you can think of is you can ignore this part and you can take this input in the start itself. Okay, or wherever you want, because you are only writing a function here and you have to use that function. So for now, you can forget about this. Okay. So now this is taking the input, it is stripping it, it will strip any ending trail spaces, and this will split it. And upon split, it will generate a list, and you will convert each number, which is string, because here you are taking the string input, to int. So what is this map doing is that it will take every element of this list and it will map to integer, and finally you will get an array of integers. Okay, so this will work something like this. First you have the numbers 2, 3, 4, 5, and let's say 1. Next it will create a list something like this: 2, 3, 4, 5, and 1. And now this map function will convert it into integers, and finally you will have a list. All right, so that's all with taking the inputs. Now you want the output. So what are the parameters you are giving to insertion short one? The n value, which is the number of elements in the list, and the list itself. And now you have to write the solution here. Now think of it, if you know that you have to rearrange the last element somewhere in this list, what you can do is you can take that value and assign it to a variable. So I'll say last value. Last value equals array of -1. Okay, so this is one way that you are initializing a variable. Next, now what should I check here? I have to check it with every other element starting from -2, -3, and up till 0th index. Yes or no? Clear till now? Thumbs up, thumbs down. Okay. So here you have taken the input, you have converted it into a list of integers, and in the function you are giving both of the parameters, which is the length of the list and the list itself. And the first variable which you are assigning is the last value, which you want to rearrange. Now next thing, think of it, what should I check it with? I have to check it with -2, -3 index and up till 0. So that is why you can use for range, and it has suggested me. So for range from n-2. So for I in range n-2 to -1, -1. Okay, so now what is this doing? Think of it. Currently, this is a 5-element list, right? So this is range from 5-2, that is 3, to -1. So what will 3 index be? This is 0, 1, 2, and this is third index. So from third index, it should go in reverse direction to third, second, first, 0th index, and then itself. So why itself is discarded? Because you know that the ending part is not taken into consideration. So it will just go from n-2 to 0 because it's in the reverse direction. So this is your step. Is this part clear? Any doubts in this? Thumbs up, thumbs down. Any doubts in this? Okay. Now you have to check if that particular value is bigger than the last value or not, bigger than or equal to. Saran, you can put it in chat box, and I have repeated it many times. Okay. So coming back. So now if array of I is greater than last value, then I'll replace the I plus 1 index with the previous value. Okay. And what is this line doing? So now, first of all, let's understand these two lines. So you have array of I. So first element it will check is third index. So third index, if you check here, what is it? 8. So 8 is greater than 3. So it will go into this line and it will assign the fourth index number with third index number. So it will assign this 3 the value of third index. So that is 8 itself. So this will be printed if you print the elements of the list, correct? But how do you print it this way? Because if you directly use print array, then it will not work correctly. Because let's say I remove pass, I run this function. Just a minute. Yeah, I run this function and I give it the input. So first 5 and then this space separated. So 2, 4, 6 and 8 and 3. So 2, 4, 6, 8, 3. Enter. So you can see it has printed it that way. But you do not want this commas and the square brackets. So what you can do is you can unpack it. And how do you unpack? If you have a list and if you add an asterisk before it, this will unpack the values and print it space separated. So now what will happen is it will take this all elements and it will print it by separating it with the space. So now let's run this once. 5, 2, 4, 6, 8, 3. So 2, 4, 6, 8 and 3. And let's say I give some spaces also. So you know that how is this R step working. Enter and it works this way. Alright, so now you have the intended output. Alright. So this is how you unpack the values of list and print it. But if you do not understand this currently, or if you can't remember this, what you can do is for I in range of length of array, print, what you can say is the ith number. So I is the index and under curly braces, and you can use f string. And you can say this should end with a space. So ends with a space. Now let's try this out. 5, 2, 4, 6, 8, 3. So now you have it this way. But what is happening? So once it is printed, it is ending with a space only. So it is continuing the next iteration also. So this is one of the iteration and this is the parent iteration. So this is a nested iteration. But after this, you want to print a new line also. So what you can do is you can print new line here. So \n and you can run this. Let's run it again. So 2, 3, 4, 6 and 8. Okay, this did not. Okay, this is already sorted, right? So let me rerun it and give it the correct input. 2 was 2, 4, 6, 8 and 3. 2, 4, 6, 8 and 3. So you can see here you have a new line character after each line. So this is also not intended because here you do not have new line character after each line. Correct? So what is the correct way to do this? So what you can do instead is you can say let us have a value, let's say string L for suppose, and plus equals dot join array of list, or you have already used for loop here. So what you can do is you can say string of I and you can give it a space here and you can print it this way. So what you are doing is you are keeping on adding it, and after this iteration is done, you can print L and then you can say L is empty string. And before this also you can say L equals empty string. And now let's run this. So 5, 2, 4, 6, 8, and 3. So now this is correct way. Okay. Clear with this implementation? Any doubts here? Okay, not clear. What is not clear? Sir, why are we using R strip? That I already said, right? Look, you have strip function, and if you have checked cheat sheet, there is also L strip. So R strip is for stripping white spaces or characters from the right hand side, and L strip for left hand side. Okay. And what is not clear here? Explain array wala part. This is already explained, right? What is it doing? It is starting from the second last index and it is going up till first index in the reverse direction. Yeah, we can also use just strip. Look, for now, don't worry about this. If you have not understood it, watch the recording. You can watch it currently also in YouTube's live stream. You can just scroll it back. Okay. So for now, first say for people who have understood the array part and the strip part, is this part clear, which I've just explained? Not clear. Okay, was this unpacking of list clear? How did I unpack it? So this is just the syntax part. Okay, all right. Then try remembering this only because this is more efficient way. And if you cannot understand this, watch the recordings once again, and you can understand that how do you format it. So what am I doing here is I'm iterating through every element of the list, and I'm printing it and then a space, and I am adding concatenating it to a variable, and I'm printing that variable. Hence, what output I am getting is the indented one, and then I'm just saying that let's make the variable again empty, because if I do not make it empty, it will print this, and again it will print the same thing again with concatenation of this particular string. So if I do not use this, and already here it is initialized as empty, so 5, 2, 4, 6, 8, 3. Okay, it still works because after going through this, it is coming back to this for loop, and it is again assigning it empty string here itself. So that's not a problem. Okay, all right. So that is also fine. But sometimes in some conditions, if you have many nested loops, it may so happen that after printing something, you have to again reset its value. Not in this particular case because it is resetting it here itself, but in some cases you may need it. Okay. So now is this part clear? Others also? Okay, all right. And first of all, we'll focus on the main part because here it was about logic building. So for now, don't worry about this map and R strip. You can use it later on also or watch the recording. Okay. Now moving on to next part. After you're printing this, you need to print the final value also. That is 2, 3, 4, 6, and 8. Correct? How do you do that? Any idea? So for now, I'll just use the unpacking syntax. Any ideas for this? That how do I print the final array? You can write it down in chat box. Okay. Array I plus 1 equals val. Where? Should I write it in if block? Should I write it in for block? Where? Where should I write it? Yes, we are discussing DPP2. Another if block. Or else should I write it in else? It should be in else, right? I can write it in else, right? So I can write else and here I can give it the value. Yeah, it has already suggested it, and then I can print the unpacked list. So how do I unpack again? By putting an asterisk towards the front. And how will it unpack it like by default? With a space, with a white space. So now if I run this, 5, 2, 4, 6, 8, and 3. Now this works well. So this is your input and this is your output as expected. So clear with this particular part, implementation, main logic building, everyone? Yeah, else and break. Break is not exactly needed. Okay, yeah, break is needed because eventually, if you have a number which is previously itself good enough, then you did not go inside it again. Okay, so let's do break then. And wait, I'll show you an example. If you do not use break, then what happens? What is wrong with it? So now let's say I have 5 and I enter, let's say 2 or else 1, 2, 2, 4, and 3. And I enter this. So now you can see this is not exactly correct, right? 3 should be in second place. So here itself it had to stop, but it did not stop. Hence, break is required here. If you do not put in break, then for some cases it would not work well. So, like, did you get why should I write break here? Because once this is satisfied, I'm fine with it. My array is sorted. So I need to break out of the loop. Hence, I'll put a break statement here. And I'll run it again. Let's check if it is working well. 5, 1, 2, 2, 4, and 3. So yes, this works correctly. All right, clear with this? So break is also important here. So any doubts in the final logic of implementing this function? Okay, all right. Now moving on to next part. So in this particular question, you did not have to write code, but you had to debug the code. Sometimes it so happens that you are giving your OPP, you are writing your code, and you face some problems that some test case passes and some does not pass. Then how will you debug that? So that is with help of dry run. And also second thing here is that this insertion sort is not only for last element, but it sorts the whole array itself. This is jumbled. This is the length of the input or list, and you have to sort it completely. So now let's try visualizing this itself here. Okay. So now you have insertion sort, and then you are providing it a list. You are iterating through all the indexes, right? First thing is that j equals I minus 1. So what would be j value initially? 0? Yes or no? Thumbs up, thumbs down. J value will be 0. Now let's say key value is first index. So that is second element of the list. And as soon as it goes to this line, you can see j is greater than 0. So 0 is greater than 0. It will not go inside this while loop and it will exit the for loop itself. So it will not go inside this while loop itself. Correct? So that's an error. So you have to rectify that first. So if you rectify that and try running it. So now let's say I give it the same input 6 and 7, 4, 3, 5, 6, 2. 7, 4, 3, 5, 6, 2. Enter. It has sorted the list. So this was the only error here. And how do you know it is the only error? You have to hit and try. After you debug this particular part, you have to submit it again. You have to check if all test cases are passing. If it is passing, then you are successful, and if it is not, then you have to check for other errors too. All right, are there more errors here? Any idea? There are no more errors, because if you have attempted the DPP correctly and if you did this question correctly, this was the only error. Yeah, I would explain that, but that is not needed for OPPs especially, because that's a different concept. And in OPP also, you will majorly have the template. You will not always have the blank code editor, right? There are some gray parts where the prefix code is present, right? Majorly, we'll in today's session focus on DPPs, and about if name equals main, we will discuss it in the last question, because last question you had empty code editor. Okay, so clear with this question? Question 6 of the DPP. Any doubts here? Okay. Now moving on to prime sum. So what was prime sum question about? First, let's understand it. So this input says that how many test cases you have to check. And this particular line means that you have a number 10. Can you write it in, can you write it as sum of two prime numbers? It could be same prime numbers, it could be different prime numbers. But can you write it that way? That was the question. So think of it. Can you write 10 as sum of two prime numbers? How? Which 5 and 5? Correct. Any other combination is possible? So in this particular question, you do not worry about other combination. If you find any one combination also, you have to say yes, 10 can be written as sum of two primes, whether or not the primes are similar or distinct. So yes here. And 1 can be written as sum of 6 prime? No. So no should be printed. So now let's go to the logical part. So this, how do you take the input and how do you sample out the output? That is just here. So you can check here how you are taking in the input. You are taking in the first input, first line. You are splitting it. Again, you are creating a list, and you know that it is of two values, right? That is 10 and 2, because here you gave only two values. So you know that this particular list which you have created will have two values, that is 0 index and 1 index, and you are converting them to integer. And before this, what you are doing, you are taking in the topmost input, that is the number of times you have to run this query. So you are running it, you are taking in the inputs, you are giving it to a function, and you are printing the results. Okay, so just understand the flow, do not go into syntax. So flow is clear here, how you take in the inputs and give out the outputs. And also check one more thing, what type of output should your solve function give? String, which is yes or no, because it is directly printing yes or no, because it's directly printing the written value which is stored in result. So remember that while solving for this solve function, you have to return yes or no as strings, and this will print out the results. So this was your default code present in your code editor. Now let's go to logic. So now you know that you have a number n, you have a number k. Now think of it, if k is equal to 1, what does it mean? It means that, can I write n as sum of one number? Meaning if n is prime or not, correct? So whenever k equals 1, you have to just check if the number n is prime or not. So now let's write that particular case. So basic case, like if k equal to 1, then I have to just check for if n is a prime number or not. So how do I check that? Let's create a is prime function which takes in a number and gives out the output that if it is a prime number or not. So now let's say I define a is prime function give it an input n, and now I say if n is less than or equal to 1, return false. So why false? So false that it is not prime, and if n equal to 2 or n equal to 3, return true, because 2 and 3 both are prime. And now for other numbers, what you can do is for I in range of 1 to n to the power zero point 0.5, because square root of n. We discussed this function initially also, right? So integer of n root n, and for this you will check if n percent I equals 0, return false, else return true. So this is one way. But now if you want to speed up this process, so this we had already discussed, right? Now if you want to speed up the process, what can I do? I can check for more basic cases here itself. I can check if the number is divisible by 3, 5 or 2. Of course it won't be prime, correct? So let's do that also. That if n percent 2 equals 0 or n percent 3 equals 0, then return false, because we have already checked if n itself is prime, then it will return true, else it will return false. Now let's do it for 5 also. If n percent 5 equals 0, return false. So think of it, is there any flaw in this function? Yes or no? Is there any flaw in this function? Will it give true for any prime number? Like colon, okay. Okay, after adding colon, what is the next flaw? N equals 5, false. Why? Think of it. When n equals 5, it will return false, like it won't go into this block, because 5 is not less than or equal to 1. It is not equal to 2 or 3, so it will not go inside this block also. And this is also not correct. It will return false for this and this. So when it goes here, 5% 5 equals 0, so return false. So here you did not check for the edge case when n equals 5. Here you had already checked 2 and 3. So if n itself is 5, then you are returning false, but that is not correct. So what you can do is you can write one more line here, and n is not equal to 5. So this is one way. Clear? Any doubts in here? Similarly, you can do for some basic starting prime numbers, let's say 7, 11, 13. Okay, that will speed up the process. Okay, so let's keep it this way for now, because it is logically correct. It will now return true or false. If the number is prime, true. If it is not prime, false. So now this function is clear to everyone, correct? Also, this part is clear, that why are we writing this? To speed the process. Because if there is a big number and you are checking for 1 to root n numbers, it is not viable. You have to break somewhere in the start itself. So you will solve it directly for some basic cases also. So now this is clear. Now coming back here. So now what I can do, I can use is prime. So if is prime n, because it is returning true or false, I can directly write in the function here, return yes, else return no. Clear with this? Any doubts in this part? Anyone? Why range to root n? That I was discussed in the second, in the second session after the orientation. You can watch it. That is to speed up the process again. You can also check it from 1 to n, but that is not needed. Just think of it. If you have a number, let's say 12, and you write its factor, so it is 1 into 12, 1 into 12, 2 into 6, 3 into 4, 4 into 3. So you can see here, now the factors will keep on repeating. So it was only necessary to do it up till root 12. And what is root 12? It would be some number 3 point something, right? It would be some number between 3 and 4. So that is why it is only required to check up till root n, and you need not check all the numbers up till n. That is just waste of the compute power. Okay. Now coming back here. Now second case is that k can be any other number, that is 2, 3, 4, or any other number, right? So now how do you solve that? Anyone? Yes. Anyone, any ideas? How can you check whether this n can be written as sum of two primes? If k equals 2 and if n percent 2 equals 0, return yes. Okay, you are saying this if k equal to 2 and if n percent 2 equal to 0, return yes with a capital Y. Yes. Why is this true? So here comes the mathematical concept. This is just to make our brain sharp. You won't have this type of questions in your OPP for sure. And I don't know if you may have one or two, but most probably no. And why does this work? Think of it. You're checking if n is prime. No, you're checking if n is even or not. And if it is even, then you're saying yes. Why? Because there is a conjecture, goal back conjecture, and it was like previously discussed in the WhatsApp group also by some participants. You can find there are two variations of it. One is strong and one is weak. It says that you can represent any even number as sum of two primes. Starting with 4. 4 can be represented as 2 plus 2. Starting with 6. 6 can be represented as 3 plus 3. So this is for k equals 2. Now what for other numbers? K greater than 2. Even number cannot be prime except 2, right? Even number cannot be prime except 2. So most prime numbers are odd. So now the second case. What about k greater than 2? So if you can think of k greater than 2 or greater than or equal to 3, anyone? And n cannot be less than 2k. Okay, one of your friends has said that n cannot be less than 2k. Why is that a case? Because if n is less than 2k, you cannot represent it as sum of primes, because think of it. Let's say you have 10 and you have 6. So you need 6 prime numbers and the smallest prime number is 2. So if you do 6 into 2, it will always be 12. So you cannot represent 10 as 6, sum of 6 prime numbers. Hence, you can also say that when n is there and you have k, if n is like greater than 2k, then you can directly return no. Correct? So this is one logic. So if n is greater than 2k, return no. Okay, an even number cannot be prime except to why are you writing this? Okay, this is an old one, sorry. Right. So this is one way. If n is greater than 2k and 2 into k, so 2 into k, then return no. So clear with this part? Any doubts here? And wait, there is a logical error, right? Greater than or less than? What did I say? You have 10 and you have 6. So if 10 is greater than 2 into 6, so it is not. So it had written no, right? So this is wrong, right? What is the correct one? N cannot be less than. I'm not sure how many of you are here in the session. Can you all raise hands for people who are listening? Everyone who are listening, please raise your hands. So barely 30 of them out of 70. Okay. Okay. Half of them. Okay, fine. So it should be n less than 2k and it has to written no in that case. Because if 10 is less than 12, of course it cannot be represented as 6 prime, sum of 6 prime numbers, hence it should written no. Okay. Yeah, equal to less than equal to is not needed, because if it is equal to, you can represent it as sum of 2's, right? And 2 is also a prime number, correct? So what you can do in other cases, if n equals 2k, so 2 into k, return yes. Is this correct? Any doubts in this? So once, let's just run this for basic cases which are given in the sample test case. So let's say I run this. Okay, just a minute. This is not required for us currently. So we'll just say this will just print it here. So print result comma backslash. Run this. You are going to give one input and that will be 10 comma 6. So no. I run it again. 1 10 comma 2. So yes, it works for the sample test case. But now you have to also check for other cases where specifically it is k is greater than or equal to 3. So if you write this in better way, that in this cases you have given no and yes, but there are some other cases also which are left out. That can be solved using this particular way. So how is this working? Let's think of it. And I'll just remove this for now. I'll just comment this out. So this is n% 2. First we are checking if it is even. If it is even, then there are two cases. If n is greater than equal to 2k, then yes. And if it is less than 2k, then no. So this is one way. So this is strong goal back conjecture. Strong goal back conjecture. And how is this working? Think of it. Here you are saying that if n is less than 2k, return no. And if it is greater than 2k or equal to 2k, then you can return yes. because you know that every even number can be represented as sum of two primes or two or more primes whenever it is present. So this is strong rollback conjecture. So this is one way. And in this case, that when n is odd, then you can have this plus 1. Because think of it, you can write it as 2 into 6 plus 1. So this is one way. So that is 13 whenever you have odd numbers. So this will also work that way. So let me just use the variables which I have used in current solution. So now any doubts in this part? Please explain this part 2k. Look, when we are talking about this, what was 2k about? I gave you this example of 10 and 6. 10 and 6. Now you yourself say, can I write 10 as sum of 6 prime numbers? Because smallest prime number is 2, and if I keep repeating it, that is 6 into 2, it becomes 12. So I cannot write it now. So whenever it is n less than 2k, I'll return no. And if it is greater than or equal to 2k, I'll return yes. Because I can write it as 2 that many n times, and rest of it I can write it as prime numbers, other prime numbers. It could be 3, 5, anything. So that is how this line is working. And that is for even numbers. Now for odd numbers, you will just add a 1. That is 2k plus 1. If you are not getting the mathematical part, no worries. Learn about this conjecture. You'll get to understand it more, or else watch the recording once again. Okay. So I hope this is clear to majority. Like whoever it is clear, can you give a thumbs up? Okay, and people who have raised hand, okay, please explain else. That's what I'm saying, right? This was for even number, this is for odd number. Now let's say you had 11 here. That was odd, right? But for 11 also, you cannot write it as sum of 6 primes with this similar logic. And this plus 1 to check if it is odd or not. Okay. So now if you check if it is working, let's run this, and I say I give 1 as the input, and let's say some big number, let's say 4, 5, 6, 7, 8, 9, and I write it as sum of 100 primes. So yes, and let's take some test cases from the hacker rank itself. So this is the prime sum question, and let's say any one of you can choose the test case. Which one should I choose? Maybe you can say the one, okay, test case 7. Okay, so test case 7. So it is this way. I can't give 5,000 inputs, so I'll try the first 5. Okay, so let's try the first 5. And let me just close it out. And also before that, so this is your first 5, and also let's check the expected output so we know that we are correct or not. So for first 5 it is no. Okay, so let's check that. Let's run this again. 5, first one is 4, 7, 5, 9, 1, 2, 3, 1, 4, 1, and 1. So no. Clear? Now 4, 7, 5, 9, 1, 2, 3, 1, 4, 3, 4, 1. No. Now 4, 7, 5, 9, 1, 2, 3, 1, 4, 5. 1, 4, 5. 1. No. And then it is 147. No. And then it is 149. No. So clear with this? Any doubts in the logic? Not the logic, but the implementation. Forget about this two line if you have not understood. You can check that again. But at least this part is clear, right? Any doubts in this part? Logical doubts also. Any doubt in the implementation of this particular part? Okay, if I run the code on HackerRank, we will not be like able to see the test case. I have to again open it if it is correct or not. Okay, that is why I'm running it here. Now let's move to the final question, which is question 5. And let me get that question. Just a minute. So we have all the smallest weight. Instead, I'll share the HackerRank platform itself because I do not have time to take that out. So can you see the HackerRank platform, everyone? Yeah. So here currently, let me go to my submissions and 3.6. Let's copy this and understand it. So I'll make you understand this code because it is quite big and there is optimization techniques also used. First of all, we'll keep it simple. We'll keep it logical. I'm not going into the code, but I'll say the logic correctly. So first, let's understand the question. So question says, and should I zoom in more or is this fine? Others also? Okay, fine. So here you have the smallest positive integer n for which n square plus 1, n square plus 3, n square plus 7, n square plus 9, n square plus 13 and n square plus 27 all are consecutive prime is 10. That means they are saying that 101, 103, 107, 109 and 113, 127 all are consecutive primes. That is, between them you do not have any other prime number and n is such small number such that all of them are prime. And the sum of all such integers n below 1 million. So 1 million is 10 lakh. All the integers below 10 lakh for which this property is true. Such that when you do n square and add this numbers 1, 3, 7, 9, 13, 27, you get them to be consecutive primes. So they are prime numbers also and they are consecutive also in the set of primes. That is this sum. So similarly, you have to write a code such that you find sum of all integers n below a given limit L. So here the limit is 10 lakh. So think of it as L equals 10 lakh. And here A1 to A6 are these numbers. But for our particular purpose, A1 to A6 can be any number between 1 to 40 and they will be in increasing order. That is, A1 will always be less than A2, A2 will always be less than A3, similarly A4, A5, A6. And the L limit, it can go up to 10 power 7. So what is 10 power 7? Anyone? It's 10 lakhs, 1 crore. How many zeros do you have in 1000? 1 crore, right? Because 7 zeros meaning 1 crore. 10 million is 1 crore, right? So whenever you have 7 zeros, it is 10 million or it is 1 crore. And what is T here? So T is the number of test cases which they are going to give. So it will be always 1, 2 or 3. And the limit can be up to 10 million. And A1 to A6 are increasing numbers and they are between 1 to 40. So clear with the question, what is our goal? Any doubts here? L is this limit, 10 million. So look, what is this particular line saying? That all such integers where you take n square plus 1 to n square plus 27, they give you consecutive prime numbers, and all such n, if you sum it up till 10 million. So up till 10 million, how many n's you have? First n is 10. Next n could be any other number. You have to find that n and you have to sum them up. And that sum you have to return. So that L is your 10 lakh. Your output is your sum. And this A1 to A6 is this 1, 3, 7, 9, and 20, like 1327. But this is just a sample test case. The original values can vary from 1 to 40 for all the A's in increasing order. L can be from 1 to 10 million, and T can be 1 to 3. So 3 test case at max for one particular sample. So it is not that 3 test case, but 3 test case at once. So if you see the sample, let's see the results, and let's go to some test case. Let's say this one, download it, input. So you have 3, you have that limit L, and these are your A's. So this is A1, A2, A3, A4, and up till A6, and these are in increasing number between 1 to 40. So this is first case, second case, third case. All right. So clear with the question? Any doubts in this? Thumbs up, thumbs down. Okay. Now you yourself think there is one simple logic that you iterate through all the numbers from 1 to n, and inside that for loop you will calculate this number for every n, that is n square plus a1, n square plus a2, n square plus a3, and for each number you will check if it is prime. If it is not prime, you will directly break out of the loop and return, like you will not add that in the sum. Correct? So now let's try writing that code. So this is clear, right? Now I'll go back to Google Colab to write the code, and finally, after building the simple code logic, which will not, of course, give you correct marks in the HackerRank platform, because HackerRank needs optimization also. So I'll come to that later. Okay. So coming back to Google Colab, and you have your A1, A2, A3. Then you have your limit L, and then you have your number n. So for I in range of 1 to n, and then you say calculate the numbers, that is I square plus 1. But you need not start from 1, because they have already given that the smallest number is 10. So start with 10 itself. So 10, and then I calculate all the numbers. Let's say I give the array here. So A equals A1, A2, A3, A4, A5, A6, A7. We'll take in the inputs. I'll give this code later. Let's just assume that these are the parameters, and L is your limit. For now, let's take 1,000, 10,000, lakh, 10 lakh, so 1 million. Now let's say you calculate them. So you say primes is equals to I square plus A of I, or else let's say A of 0, comma, or else let's write it in one line. So for I in range of length of A. Is this line correct? And if it is correct, can you understand this line? Any doubts in this line? Anyone? What am I doing? Okay. Okay. What am I doing here? You have I square plus AI. So you are doing n square plus A1, n square plus A2. You are collecting all that numbers here. And we'll ensure that here the data type is integer. So let's say here, let's keep the data type list of int, and let's comment this line out. But let's let it be like that. And let's say this is an integer. Okay. So now you have this, and here the limit should be L. No one is telling that. Here I have to correct it, right? It is L because I'm checking up till L. So finally, let's go to next line. Now you have that is prime function. I'll just copy paste it here. So is prime function, and I'll use that. If is prime primes, print primes. So what is this doing? It will take all the elements of this and it will check if all of them are true. So what will happen here is, if it is like something like true, true, so what is happening here is that you are giving this function a list of values and you are checking for all of them. But you cannot do that, right? Because here the is prime function is taking what type of input? It is taken an integer, hence you can write it integer and returns a boolean value. So here you cannot give it this way. What other thing you can try checking here? Any ideas? I need some list like this, and if all of them are true, then I'll add that ith number to my sum. Any idea that how can I write this if block? Won't AI be out of index range? No, it starts from 0 and it will go up till length of A minus 1, right? So it won't be out of index. Okay. Loop. Okay, so I'll check the loop, but then that will become complicated, right? Is there any other way? Yeah, you can of course do this, that you write for I in primes, and then you can create a list primes truth equals empty list, and then you can append this value. So prime truth dot append is prime, and then you can check for that if primes truth, then you can primes truth, so s also, then you can print the primes and you can add it to the sum. So now let's say I'll maintain a sum variable here, sum equals 0, and I say sum plus equals I. So this is one way, correct? Okay, someone want AI be out of the list index range. Let's do a dry run, right? Why will it be okay? Wait, there is one more problem here is that I've used I here also and I here also. So list out of index, out of list index is a other problem, but first we'll have to deal with this problem. So yeah, this is now better. Okay, yeah, this is better, and it won't be out of index because if you think of this I, think of it, right? If you have a list, here you have 6 elements. So let me remove this 7. So it will start from 0, 1, 2, 3, 4, 5. It won't go up till length of A, right? Clear? Okay. And this was the error that we had same variables. So Python would get confused. I has to be taken from here or here. Okay. Yeah, previously both were I, so it was confusing, but now it, we have changed the variables, so it is better now, right? So now if primes root is there, then sum plus equals I. So this is your simple logic. Any doubts here? Is there anything missing here? Let's try running it from for a small value. Yep. Let's think of 10 itself. Okay. So I'll give it a range of 11. And also first let's understand how do you take the inputs. So if you go back to the hacker rank page, so inputs were taken as 1 and then the limit and then the A's, right? So let's take the sample input, sample output, coming back here. So this is your sample input and this is your sample output. Okay, now let's take the sample input first. So input, first let's take the value, this value. So t equals int of input, and then I can get this whole thing inside this for loop, which I'll be writing here. For in range of t. Okay, so clear with this part. How am I taking the input, and I'm zooming out because so this is fine, or should I let it be zoomed in? Yeah, and j raised to the power 2. Yeah, sorry. I usually do this mistakes because I am used to writing latex also. So okay, yeah, correct. This is also a mistake that I have to use the operator for Python, and for power it is double asterisk, not the hat symbol. Okay, okay. So be careful of errors like this. Yeah. So coming back to the input is taken here. Now I'll take this to input. So first the limit. So L equals int of input, and now I can forget about this. Let's shift it down. Uh, okay. Sum is 0, and now let's take the A's. So what we can do is you can use this. Look, it has already given this. So this is also one way that you can use. What you are doing is you are taking in the input, you are splitting it, so you have a list and you are mapping it to integers. So how does map function exactly work? Let's check if our cheat sheet has it. Let's go to cheat sheet, control F map. So you have map here, but this is not exactly correct. But you can see how the map functions works. So instead of map, what I can do is I can use this also. So I'll come back here, and instead of this particular line, uh, I'll write the map function in some other way. So A1, and here I'll start a list, I'll end a list, and I'll say int of I for I in this list. So this is how your map function works. This is similar way. Okay. So is this clear? Any doubts here? Any doubts here? Anyone? If you have any doubts, you can like ask, because this is an important question. You should understand it well. So, any doubts in this complete implementation till now? We have taken the first input, which tells us how many cases we have to iterate for, and return the input. Sorry, return the output, and then you can write it. So I've taken in all the A's. I created its list. Yes. Any doubts here? And here the position matters, because here you will have a list of 6 values, so you can use it. And this is extra step. You can use it this way also. You can directly use it this way also. So instead of A, I could have written A here directly. Else wait. This is one way, and this is another way. Directly using this. Okay. So any one is fine. So first way, second way, and this is your third way. Yep. So any doubts in this? No, right? All 3 implementations clear? All right. Now let's move to here. So how does your output look like? It has to give the sum. So let's take the sum. So print sum. That's it. And this will always print in new line itself. So that's not a problem. And you can print the sum because it has iterated through the range. So now let's try this. Okay. I'll remove the sample input. I'll remove the sample output. And this is your whole function. So you have s prime. Again recapping. So this is s prime returns Boolean value. Then here you take in the first input, which tells the number of cases it is going to give you. And for each case, you take the limit, that is the first value. Second, you take all the values of A's in increasing order. And finally, you compute the sum. And then you print the sum. So now let's run this. So one case, and let's say 11 is your limit. And all the A's which I will be giving is the same as this one. So it's 1, 3, 7, 9, 13, 27. So 1, 3, 7, 9, 13, 27. Enter. Why is it giving 127 as the answer? Okay, I'm using I here. So for I in primes, I'm summing up the primes, but I need to sum up the value j. Okay, again, look, here it was I initially. What it was doing, it was summing all the prime numbers. So this was of no use, and it was just summing up this particular list and giving you the output value. Okay, fine. Probably now it should work well. No, wait. This if block wasn't inside this particular I. But it's Python and it did not raise any error, but it was taking that I from somewhere else. I'm not sure where. Okay. Okay, now let's try this again. 1, 3, what were the other numbers? 7, 9, 13, 27. 7, 9, 13, and 27. Okay, still there is problem. It should have written 10 itself, but it's not returning 10. Why is that the case? Let's debug this. Anyone, any lines which you find errors in? Look, you are taking the input. Okay, let's print some values here. Let's print L, print A. Um, let's so this is happening for all the values. So let's print primes truth and enter 1, 10, 1, 3, 7, 9, 13, 27. So okay, limit is printed, all the values of A is printed, and primes truth is not printed correctly. Why is primes truth not printed? So for I in primes, let's print primes first. 10, okay, not 10. Let's run it again. 11. 1, 11, and next numbers are 1, 3, 7, 9, 13, 27. Okay, yeah, now it's correct. So you have 11, you have your list of values of A, then you have all your prime numbers, and then finally your sum. Okay, all right. Let's print prime fruits again. Okay, prime fruits. Just a minute. Yeah, prime fruit. 11, 1, 3, 7, 9, 13, and 27. Okay, so this is the final one, and it's false. Yes, someone has raised. Yes, Karthik sir.
Yeah, sorry to disturb, sir. Like, I guess Athav Patel is here, I guess. Athav, hello. You are facing some doubt. I would be requesting to ask, sir, please.
Wait,
Okay,
I'll.
you are, yeah, you are in live session.
Okay, and Karthik sir, can you find the error here? Like, what's the problem here? I am not. Like,
Sir, which one question?
the last question, the basic implementation without any optimization. So I've taken the input,
Yeah.
limit all the values of A. I'm printing L and A. It's printing correctly. This is your L and this is your A. These are your inputs, and then this is the logic. And is prime is not working well. It's returning false. So there is some problem
Yeah.
here.
Yeah. I'm sharing a simple kind of thing in your WhatsApp, sir. I would be requesting to please check.
Okay, all right. But let's first debug this. Yes, Devam. You can talk. I have like given the permission for microphone to everyone now. Yeah, sure, Atharva. Prime I not is prime I guess.
Like I've shared,
Here,
sir. Shared for the whole thing. Fine. The
okay,
actual implementation with all the kind of
okay, all right. I'll work with it. Okay, just a minute. And today's session is a little longer, but let's solve this first. Yes, Atharva, are you able to unmute your mic? Okay, first let's take that WhatsApp code and then I will debug this. And people who want to stay and look at me debugging the code can stay, and others who want to leave may leave. I'll share this above codes and solutions soon. Okay. Can't unmute. I can chat. Wait a minute. Why aren't you able to unmute yourself? Check once again. Check it once again. Can you check? Are you able to unmute now? Always try like rejoining the meet. Maybe the permissions are not updated to everyone.
Sorry to disturb once again, sir. Like few
Yes,
things I
please.
have to say, guys. For the yesterday DPP, no worries if you are like going for the simple ones. Fine. Make sure to complete. Only go with the logics and kind of things. No need to like कि भाई ये नहीं हुआ कोई दिक्कत नहीं. Make sure करना है कि खाली you have to accept the challenge, work on it. नहीं हो पा रहा कोई issue नहीं. You can ask in the meet or in the WhatsApp group itself. Thank you, sir.
Thank you. Yes, people, are you able to unmute yourself? Anyone who can? Okay. Then, Atharva, if you are present in the meet, then you can speak up.
I guess he's facing a problem from his side. He's yeah.
Okay, nothing wrong. Okay, then how will you be able to explain?
He's saying कि I would just like overall code brief explanation again. I have understood it in parts.
Okay. Okay, all right. Okay, then I'll try debugging this. You already have a code here, which is this one. Let's try running it once. Uh, okay, name is not defined. Okay, let's just run the main function directly. Yeah, okay, we are not taking any inputs here. Okay, first let's debug this one. That is better. So if n is less than 1, then you return false. If 2 or 3, then return true. Then return false. This is also fine. And if there is any number that is divisible, then you can. Okay, here I have taken the range from 1, right? Yeah, I got the debugging part. Here I have taken the range starting from 1. So n% 1 for any number n will always be 0. So it will always return false for any big prime number, which is other than 2, 3, or 5. That is why this is the problem. So error over here. Change range 1 to range of 2 and so on. And instead of 2 also you can skip 2, 3, 4 and 5. You can directly start with 6. All right. Let's enter it 1, 11, and your numbers 1, 3, 7, 9, 13, and 27. And now it works perfectly fine. Now let's do the same for a test case from HackerRank. Okay, let's go to HackerRank. Let's go to submissions. Let's go to view results, and let's try a failed case only. Download, input. So these are your inputs. Let's try it for a big number for now. Let's see if it like we'll wait for some time to run it. Okay, and we'll go back to our code, and let's also check its expected output. So expected output, it is 20271. Okay, let's go here and Print this out. So this is your input, and this is your output. Input and output. Yes, someone has raised your hand.
Yeah, sorry to disturb once again, sir. Like few things. Someone is commenting, they can leave. Yeah, guys, you can leave if you
Yeah,
are not facing any problem. If you are facing problem, so one by one you can simply raise your hands or you can comment it down.
yeah. And finally, we have debugged the code. The debug was present here, which was starting from 1, and 1 is divisible, so it will always return false for bigger numbers, bigger prime numbers. And now we are going to run it for this particular number. So 9943395. Yep, it's correct. And then the values of A: 7, 9, 15, 25, 37, 39, enter. And now this is going to take some time because we have not optimized it. It is going to loop over every number up till this value. Okay, so for that much time we can discuss about doubts. So you can ask your doubts if anyone has any doubt.
Now I guess there are only 14 left. Guys, if you are we are waiting for only 5 minutes. After that we are going to end the recording.
Yes, correct. Only for
If
the
you are
output to
facing any
arrive.
problems regarding your OPPs or kind of examinations also, so you can simply ask your doubt. No worries for the hesitation or kind.
And also one more thing, if you talk about the code which is present here below, the is prime function is a little bit differently written here. There is a thing known as Miller-Rabin. So till this runs, I'll keep it running. I'll go to my new tab and I'll search Miller-Rabin primality test. So this is probabilistic, and what it does, it is speeding. It will speed up the whole process.
Yes, sir.
Okay.
Like also the code I have shared with you is like I have tried like half an hour ago I have written and I'm trying to debug it. Like it's showing is system error, system error. I'm like, chodo
Yeah.
bhai.
Look. Even when I tried it myself, let me share the submissions. So I've tried it many times. If I go back to my submissions,
Yeah, see,
tried
see,
it
see.
many
That's
times,
why.
and my maximum score is 3.6. And
Yeah.
because many test cases are terminated due to timeout, so it is taking more time than the hacker rank allows us to.
Yes.
So not sure how people have scored 5 marks. Like some have scored
Yeah,
5 marks, right?
Soham, like Soham, Soham, like you are facing a doubt, like these questions will come in OPP. No, like these was a kind of question which I have inserted because of कि many are out of OPP. I was thinking कि क्या पता कोई कर ले
Huh.
वाली चीज.
And this is basically for logic building. Look, we
Yeah,
have learned
it's
many
only for
ways.
the logic bindi. For the OPP wala part, I would be requesting you should be for the practice. You should be going in your dashboard, working on the OPP practice sets. There are like many questions found there. I would be requesting if you are doing 5 questions in a day, so it will be a very nice for you.
Correct. And for similar purposes, we have also created this cheat sheet. So this has all the required fundamentals for you to follow in your OPP. And someone in between was asking about lambda functions, not necessarily to learn that. For now, focus on building logic, because in OPP that will help you. Syntax, yes, basic syntax you should know, and of course you can use the help function also, and it is given here in the start. It's like if you click on this, it's the ending section. You have how do you use your help function. Okay, So you can work it that way. So that is about OPPE part. And coming back to Miller-Rabin primality test, so it's a probabilistic model which is running faster than your normal root and prime function. You can, if you have interest and if you have time, you can invest learning this particular concept, which is Miller-Rabin. I repeat, it is Miller hyphen Rabin. Okay. Yeah, there was someone whose roll number, like there were two people. Let's go to the hacker rank and see the leaderboard of this question once. So yes, just three people have solved it. So this is optimized code also, and I'm not sure if you can. Karthik sir, can we check their codes?
Yes, sir. Can you please repeat? Your voice was thoda sa lag.
Okay, I was saying that can we check these people's code? People who have scored 5 marks. Is it possible?
No, sir. Like their codes are not possible.
Okay, all right. What is for what? Like, what do you want to ask? I did not understand the
So
question.
I guess there is a question from Athav. I would like to learn these concept. Can we do it now? Like if you can explain Miller ribbon wala method, ribbon prime
Um,
wala method.
okay, I'll try to explain it. Let's go to the problem or else the submission. View results. So here you have Miller-Rabin primality test for 64-bit integer. So it is up till this particular limit. So first things first, this part everyone understands. So that if n is less than equal to 1, return false. If n is less than equal to 3, return true. That is 2 or 3. And if n% 2 equal to 0, return false. Now these are your basic prime numbers, the initial ones from 2 to 17, right? And now what is this part? Let's go with the variables and understand it first. So d equals n minus 1. So that is your n for which you are checking if it is going to be prime or not, and you are assigning d n minus 1 as its value and s equals 0, and you are doing this particular function. You are trying to write it as this particular manner, that is 2 to the power something into d. And what is this double slash equal to doing here? Any idea? Double slash is for floor division. So it is dividing and assigning it again, right? What is it this doing exactly? If I simplify it in terms of equal to and floor division separately, can you write that in the chat box? D equals d divided by 2, and then you are adding 1 to it. Why? Because s is your power. So the number of times you can divide d by 2, like floor division you can perform, you can keep on iterating. So you are keeping on iterating unless and until your d percent 2 equals 0. So it becomes a even number, correct? So clear with this particular part? Any doubts here? Let's do a dry run. Let's say you have this particular function. I'll just copy this Miller Rabin and I'll go back to my collab. This is still running up. Yes, someone has raised it. Yes, Karthik sir.
Yeah, like one more thing. If you guys want some higher methods of questions or like concepts also, after OPP 1, we can do a 1 day boot camp for these kind of concepts or these kind of programming things, where you can basically understand all the concepts or things. Sir, what are your views? Yeah, Devam sir. Hello.
Yep. Okay. So coming back to Miller Rabin. So here is your Miller Rabin code, and let's try this with a number. Let's say 100 or else 101 because it's prime, right? So how would you perform this? So your D is equals to 100 and your S equals 0. After you do the first floor division, what is your answer? D equals 100, S equals 0. After you do the first while loop, what will be your answer? Because 100% 2 equals 0. So 50, yes or no? Yes. So your D equals 50 and your S equals 1. Now second thing, your D equals 25 and your S equals 2. Now what is going to happen next? It will not go into this while loop, correct? Wait, 12.5, why? At 25 itself, it will not go into this while loop, right? Okay, so be careful. It won't go into this while loop now. So now your D is 25 and S is 2. Try putting it in this format. So 25 into 2 power 2. So 25 into 4, that is 100, correct? So that is your n minus 1, correct? Yes or no? So this is correct. Now after this, what are you doing? We are doing it for 101 only. Remember that these are your values, okay? Now next is for a base and bases. So you have this basis and you are iterating to its value. And you are saying if it is greater than or equal to n, so if a particular base is greater than or equal to n, so what is n here? 101. So it won't be for any one of them, right? So it won't break out of this loop. It will go here and it will use this power function. Now what is this power function doing? Let's get it back from the solution. So this is your power function. I'll copy this, come back to your collab. I'll put it in above. Okay. Now think of it. What is your power function doing here? It is calculating a to the power d percentage n. So whenever you divide a power d with n, what is your remainder? So what is this power doing again? Remember, it will return this value a power d percent n. So now what is your a power d? So a is your base. So let's check for a base between here. Let's say 11. Okay. So if 11 to the power d, so what is d here? 25. So if 11 to the power 25 is divided by 101. So let's do that. 11 to the power 25 divided by 101. It won't exactly divide, or will it exactly divide? It won't exactly divide. So you will have some remainder left, right? And how can you calculate that? Let's go into one online compiler for Python. So program is not JavaScript, Python. I want. Just a minute, I'll change it to Python. Yep. So let's print 11 to the power 25. So power symbol is this percentage n. N is 101. Let's run this. It's 10. So your reminder is 10. Okay, share this tab inside. So here you have your x equals 10. And now you check if x equal to 1 or x equal to n minus 1, which is your 100, you won't you will continue to next particular value. But that does not happen here, right? So it will go into this particular value and it will check, it will assign, it will check for s minus 1 time. So what is s here? 2. So it will check for one time only, that is 0 at number, 0 at iteration, x into x percentage n. So what is this? 100, 101. So what will its value be? Of course 1, right? And if x is equal to n minus 1, then you break and else return false. So it will go into this else block when? When will it go into this else block? Anyone? This else runs if the for loop completes without break. Correct? So it does not go into this. So this is one of the probabilistic models. Now it very much depends on this basis. So you need to have some basis particularly, and you need to determine it in such a way that your hacker rank conditions satisfy, which is these ones. So I'll not go into discussing more because it's already 1 hour 50 minutes. Okay, all right, and we'll check the output here if it has run. So it is still running. So this will take much time, but I'll share the output once it runs well. And I hope that it is same as this one, 20271808. Okay, fine. All right, then I'll stop live streaming. And for live stream people, I'll comment it down in the video. Yes, Disha. Let me stop the live streaming first. Thank you, everyone.
Yeah, thank you so much, sir. Thank you. Like it's 2 hour. Yeah, Disha.